So let's start with the first couple of questions that I ask everybody is what I'm just doing a live in my instructor group. They can't see you,
That's fine, yeah.
but I want them to see what we're about to talk about because a lot of people have these problems as well.
Yes.
So the first question that I asked him was, what provides electricity to the spark plugs? And he answered correctly, the magnetos. And I said, well, how do the magnetos create electricity? So that's what we're talking about right now. And step number one is we talked about a horseshoe magnet with the North Pole and the South Pole. And here's a piece of copper wire in the middle that if we have these two poles and you draw a piece of wire through it, it's safe to say, assume, and understand that between the two poles, it would hold on to the electrons, and as you pull the wire through, the electrons would be stationary between the two poles, but it would induce a current. The same thing as if the wire was stationary, and I took that horseshoe magnet and I drew it along the wire, it would induce a current, or the electrons would flow. Okay, so that's where we're at right now. All right. So if we have flow in that wire between the horseshoe magnet, the same thing can be said if we have, let's say, a pair of bar magnets. If we were to just cut that off and have two bar magnets, we could draw it along the wire. Now I'm going to jump ahead one step. I think you can keep up to this though. Let's say I have a bar, not a bar magnet, but a bar, and I have wire wrapped around this bar. Okay, and I have a pivot point right in the middle. And then there is a horseshoe magnet on the outside of it, okay? If I were to take this bar wrapped in wire and spin it around and around, because it's within the magnet, it would still induce flow. Does that make sense? Yeah, exactly. And that's pretty much how a magneto works. So this is overly simplified, it's not perfect. But if we have that bar rotating and rotating and rotating, then it's going to induce flow. It's going to move the electrons. It's going to create electricity. But here's the sticky point. What turns the bar? What turns the thing inside of the magneto? And funny enough, it's the engine. It's engine driven. So it's it's an engine driven magneto. So it's the crankshaft, it's the spinning crankshaft that turns the magneto. Wait a minute. So if the crankshaft is the one that turns the magneto, but we need the magneto turning to fire the spark plugs, it makes sense if the engine is already running, right? So if the engine is already running and the engine is turning really, really fast, because this has to go fast to create electricity. If the bar is turning slowly, it's not going to create enough electricity. Right, so we're going to get into the starting in a second. But this makes sure that it's a self-sustaining system. If the engine turns the magnetos are spinning fast enough to create spark for the engine turns the magnetos create electricity for the engine. It's a self-sustaining system. Okay? All right. Eraser. Ooh, eraser. There's no cloth. Oh, there it is. There it is. Okay. Good. Okay. So does it make sense that it's a self-sustaining system? So the problem is now, how do we start the whole process? I just told you that the magnetos have to get going really, really fast to be able to create enough electricity to fire the spark plugs, right? Yeah. How do we start this whole process? If the only thing that turns those magnetos is the crankshaft, how do we get the crankshaft going fast enough? Yeah, yes, absolutely. So what happens is that here's the crankshaft. I'm just going to draw it as a rod. You know that the crankshaft has, okay. I'm just going to draw the crankshaft as a rod. All right, here's the spinner, prop 1, prop 2, okay? And if you look in a 172, if you look just inside the cowling, you can see that big metal disc with all the teeth in it, right? So that big metal disc is right here, and it's got all those teeth in it. Well, the reason is because if we look inside the cowling on the port side, into the bottom, there's a little piece of metal that is shaped like this, right? And it's got a little piece of metal in it with teeth on it. Okay, so this is the starter. when you turn the keys on to start, what happens is this little piece of metal pops out, it connects with this big piece of metal, they interlock, and this tiny starter motor spins this thing, which turns the crankshaft, and that crankshaft is then turning the pistons. It's external, it's being done because of the starter motor, not because the pistons are firing. And it's turning the prop through the air as well. So this itty bitty little starter motor, what provides electricity to this?
I think the battery.
The battery, exactly. There's not a whole bunch of power in that battery. And the starter motor is so small, and it's turning this huge heavy metal engine because these teeth are connecting to these, right? It pops out and it connects together. And so this tiny starter motor is moving everything. There's no possible way that starter motor can turn the crankshaft fast enough to get the magnetos firing. It's not possible. So what do we do? That click when we were outside and we pulled the prop through, you heard the click. So that click that you heard when I pulled the prop through, making sure the magnetos were off before I did it, okay, is what's happening is inside the magneto casing, there's something called the impulse coupler, and it's a spring. And so it's inside the magneto casing. And as we pulled the prop through, you could hear it, but the same process happens when the starter motor turns the prop, and it wasn't me, same process, is that the spring on the back of that magneto is winding and winding and winding. It takes 3 revolutions, let's go on the 4th. So it winds and winds and winds, and on the 4th timing, it lets go, and it goes woof. Okay, so it's a spring that as the prop goes around, or as the crankshaft goes around, that spring inside of the back of the magneto, it winds and it winds and it winds. And at a certain timing, it'll let go. So it'll click off and it'll go whoosh, and it'll unwind very, very fast.
And it makes everything even faster.
That's it. So then it's the unwinding of that spring or the impulse coupler that actually turns the magnetos fast enough to create electricity.
So the starter just when unlock the spring, it should actually turn.
It doesn't unlock the spring, yeah. It's actually momentum that disengages the spring, but that's enough.
So creates a little momentum to be able to...
Yes, which is why hand propping works without a starter. Because if you can pull the prop through fast enough, it's still winding an impulse coupler. You just got to get out of the way in time, right? Which is super dangerous. Hand propping is super dangerous. I know a lot of people watching this are going to say that they love it, but who cares? Super dangerous. So if you hand prop or you pull the prop through, it still winds the impulse coupler, and at a certain timing, it'll let go, and it'll start the magnetos, which then fires the spark plugs, which then can become a self-sustaining system.
Right.
Yeah, and that's how starting works.
Simple.
Yeah, ba-dum-bum. Okay, tomorrow's action step is Throwback Thursday, so you're going to spend 15 to 30 minutes reviewing something that you haven't looked at in a while. It could be IFR, it could be, hell, it could even be your private pilot flight test guide or limitations. It could be airspace regulations. It could be any of the air law or any meteorology, but you're going to spend 15 to 30 minutes reviewing something that you haven't looked at in preferably more than 30 days. Review, because the forgetting curve, the remembering curve is a real thing, and it takes 28 days to go from 90% remembering down to 30% remembering, so get on it. Go kick some ass, and I'll see you tomorrow.